This is AP Calculus, AB. This question was released from the 2011 AP test. This is question number 4. Continuous function f is defined on the interval that we can see here from -4 to 3 inclusive. The graph of f consists of 2 quarter circles and 1 line segment as shown in the figure. Let g of x equal 2x plus the integral 0 to x of f of t mad props to t. A, find g of -3. Also find g prime of x and evaluate g prime of -3. It's a lot to do there. So g of -3, let's do that first, says that g of -3 is equal to 2 times -3 plus integrating from 0 to -3 f of t with respect to t. Now obviously 2 times -3 is -6. This part here we're going to have to integrate. And to integrate, we would like the upper bound to be smaller than the lower bound. So to interchange them, we can do it as long as we change the sign out in front. So we got to find the area between the curve and the x-axis from -3 to 0, which is this region right here, which is a quarter circle. So to find this, we're going to have to take a fourth of the area of a circle. The area of a circle is pi r squared. The radius of this circle is 1, 2, 3. So that's going to give us -6 minus 9/4 pi. That is what g of -3 is. We weren't given any type of units, so we'll just leave it like that. Let's define g prime of x. Well, to find g prime of x, for this first part here of 2x, its derivative is simply 2. To take the derivative of this, we're going to use the second part of the fundamental theorem of calculus, which says to take its derivative. We're just going to take this variable and put it in for t. Then we have to multiply that by the derivative of x. It's going to be 1, but I'm just going to put it here so we don't forget that that's what we would have to do. Therefore, g prime of x is 2 plus f of x. Fortunate thing about this, if you forgot to use the chain rule, you'd still get the right answer. To figure out what f of -3 is, so we're looking for a y value when x is -3. Get rid of these numbers here because they're a little misleading. -1, -2, -3. The y value is clearly 0. So this is g prime of -3 is 2 plus 0, which is 2. How do you get points for part A? Well, you're going to get 1 point for figuring out what g of -3 is. You're going to get a point for finding the derivative of g prime. And you're going to get a point for evaluating g prime of -3. Move on here to part B. Determine the x-coordinate of a point at which g of x has an absolute maximum on the interval from -4 to 3. Now, absolute maximums, we're going to use the extreme value theorem, which means we got to check the end values as well as any critical values. To find the critical value, we're going to take the derivative, which we already established was 2 plus f of x. To find relative mins and maxes, we set that equal to 0. And we end up with f of x is -2. Well, when on our graph is f of x equal to -2? Let's look at it. Negative 2 is here. So at negative 2, f of x is going to be this line right here. So that line, so we're trying to find the x value. So we can't really approximate it because I don't really know what it is. I mean, we could approximate it. We couldn't find the true value right there. I'm just guessing. It looks like it's 2.5, but I don't know for sure. So to evaluate it for sure, we're going to be using y equals negative 2x plus 3. How do I know that's negative 2x plus 3? Well, I should probably talk through that. The y-intercept is clearly 3. In the slope, if I go from here, I go down 1, 2, 3, 4, 5, 6, and to the right, 1, 2, 3. That's saying the slope is negative 2. So that line is y equals negative 2x plus 3. That's where I'm getting that from. So if I know the y value is negative 2, and I want to know the x value, which I'm pretty sure I know what it is, but I'm not 100% sure, I'm going to end up with 2.5 as the x value. And you know what? I'm going to leave that as a fraction. I think that might serve me better later. So once we know what the critical value is, we need to figure out if that relative min or max is also an absolute maximum, because it could be. So we're going to use these n values of g of negative 4, another n value of g of 3, and we're going to use the critical value of g of 5 halves. Whichever of those give us the biggest answer, well, that's going to be our absolute maximum. So function g, once again, I'm just going to write this down for reference, was 2x plus integrating from 0 to t f of x, or is it 0 to x? 0 to x f of t with respect to t. So g of negative 4, that's going to be 2 times negative 4. I'm just going to go ahead and flip this around right now, make this a minus, going from negative 4 to 0 of f of t with respect to t. It's going to be negative 8 minus, well, what's the area under the curve from negative 4 to 0? Well, let me just add a little bit to this picture. This right here is going to be negative pi over 4. That's because the area of a circle is pi r squared, the radius is 1. So the circle is pi, this is 1/4 of it. We already established this was 9/4. So the area under the curve here, we got a negative pi over 4 plus a positive 9 pi over 4. I am really running out of space. That's going to make that negative 8. This is going to give us negative 8 pi over 4. And that reduces to a negative 2. It's going to give us a positive, let me write it down. It's going to give us positive 8 pi over 4, which means this is negative 8 minus 2 pi. G of 3. Let's figure out what this is. It's going to be 2 times 3. And then we're going to be adding to this, integrating from 0 to 3, f of t with respect to t. That's going to be 6 plus the area under the curve from 0 to 3. Let's see what that is. Well, looks like it's going to be 0 because this triangle and this triangle have the same dimensions. So the area from 0 to 3 is just going to be 0. That makes that 6. Right now, comparing 6 and this negative number, 6 is definitely bigger. So right now, the g of 3 might be the absolute maximum. 5 halves, we're going to have to do 2 times 5 halves, and then integrating from 0 to 5 halves, f of t with respect to t. 2 times 5 halves is 5. The area under the curve from 0 to 5 halves. Let's see what that is. So this area here is going to be 9/4. The reason I know that, area of a triangle is 1/2 the base. The base is 3/2 times the height. The height is 3. Gives me 9/4, positive style. And this area down here, let's see, it is 1/2 the base. That base looks like it's 1 times the height. Looks like that's 2. That's going to be 1 negative style. So the area under this curve is going to be 9/4 minus 1. 1 is the same as 4/4. This is going to be 5 plus 5/4. That's going to be 6.25. Boy, that's a ton of work. So comparing those different numbers, this one's clearly the biggest. So G has an absolute maximum at x equals 5/2. How did the points go for this? Well, you get 1 point for stating where the absolute maximum is. You get a point for determining that 5 halves is a critical value, and you would get a point for taking this derivative correctly and setting it equal to 0. I'm assuming that in order to get this last point, you would have to include these other test points. Alrighty, we're not done. We got part C. Look at this. Thought it was an alrighty time. Check out part C. So same function, part C. Find all values of x on the interval from -4 to 3 for which the graph has a point of inflection. Give a reason for your answer. All right, well, we know what g prime is. We've already established it's 2 plus f of x. Well, what would g double prime of x be? That would be derivative of 2 is 0, derivative of f prime of f is f prime. So in order for us to find this inflection point, we want to change where the concavity is changing. And to figure that out, keep in mind, we don't know what function g looks like. We just have this equation. To figure out where g double prime changes signs would tell us when g has an inflection point, because wherever the signs change for g double prime, that's where an inflection point is. So if you look at the graph, f prime is increasing, which is what g double prime is, from -4 to 0. And g double prime is decreasing, that's function f is going down, from 0 to 3. I'm going to write that down. G double prime is greater than 0. That's saying the slopes. Slopes are positive. On negative 4 to 0, and G double prime of x is less than 0 on 0 to 3. Once again, what does this mean? G double prime is bigger than 0 means that f prime is bigger than 0, which means the slope. Slope is positive. They're all here. From 0 to 3, slope's all negative. Therefore, G double prime, which is the same thing as f prime, changes signs at x equals 0. Thusly, g of x has a point of inflection at x equals 0. How do you get your points for this? Right here is how you get your point. This is worth a grand whopping total of 1 point, I believe. Part D. Find the average rate of change of f on the interval from negative 4 to 3. Let's do that first, then we'll read the rest of the question. To find the average rate of change, it's just old school slope. Going to do f of negative 4 minus f of 3 over negative 4 minus 3. That's a negative 1 minus a negative 3 over negative 7. That's going to be 2 over negative 7. That is the average rate of change. Do that correctly, you get a point. Second part of the question. There is no point C from negative 4 to 3 non-inclusive for which f prime is equal to the average rate of change. Explain why this statement does not contradict the mean value theorem. Let's look at the graph. Well, here's a reason. The graph is not differentiable at x equals 0, and for that matter, it's not differentiable at x equals negative 3, because here we'd have a vertical tangent, and here we have a cusp. The mean value theorem cannot apply if f of x is not differentiable for each value on negative 4 to 3. F of x is not differentiable at x equals negative 3 and x equals 0. You'd probably get full credit for that just for saying one or the other, but I'm not 100% sure, so I'm just going to mention both. You get a point for saying that. All right, that concludes 2011 problem.